Hello, and welcome to the FlipRobot e-learning module. In this module, we'll be looking at the default firmware modes for topics 1 and 2 of FlipRobot and how to program these modes using the variable control board. In this course, we'll cover the following topics: the function of firmware and its importance in robotics, using the remote control, programming the ultrasonic sensor through the variable control board, programming the LED lights through the variable control board, and programming the infrared sensor through the variable control board. When you finish this topic, you will have learned what firmware is and its application to robotics, how to use the remote control to move FlipRobot, how to create obstacle avoidance programs with the variable control board, how to change the LED lights with the variable control board, and how to create line tracing programs with the variable control board. Firmware is a term we hear more and more with technology becoming increasingly important in day-to-day life. Whether it be your smartphone, work laptop, or even some home appliances, the need for firmware and firmware updates seems to happen on a daily basis. Have you ever stopped to think about these updates and what they're doing to these devices and what the firmware's purpose is? Firmware is a set of instructions programmed onto a hardware device which provides the critical routines that piece of hardware requires to operate. For most electronic devices, this includes items such as the boot up sequence and many standard modes the device might have. It also provides the necessary instructions for how that device communicates with other computer hardware. The set of instructions that firmware provides is important because it provides the device with the fundamentals of how to function. To put this in perspective, if we were talking about the default firmware for a human being, it would include actions such as blinking and breathing. These are not taught, but are instinctual to us as humans. Default firmware for machines provides the same instinctual information to perform tasks such as startup procedures and how to interact with its default sensors. This is how you can program each of the sensors using the default firmware, as the FlipBrain will have information on each sensor and the information needed to utilize them. Each extension kit has its own default firmware for the various sensors and auxiliary components that come with each extension kit. When using the default firmware of FlipRobot to code, there are two key components for the robot that make this happen, which we will look at now. The first is the FlipBrain. This is where the set of instructions are stored, as well as being the processor to govern how the outputs will react to programming. The second is the variable control board. From your time assembling the robot, you will have noticed the variable control board plugs directly into the FlipBrain. This is what allows the variable control board to be able to program FlipRobot without the need of a coding platform. By turning the numbered dials on the variable control board, you can program the robot with various sensors depending upon the mode you are in. We will shortly go through each default firmware mode and learn how the variable control board functions in each of them. The case curriculum for FlipRobot is designed to gradually introduce students to concepts behind coding by utilizing what we have called the 3 levels of coding. As students progress through the levels, they will gain the knowledge and competencies required to better understand the next level of coding. The first level is robot control without coding. This involves using a remote control to power both DC motors of FlipRobot. Using a remote control to power a robot is something that is very easily identifiable, as most people have had experiences with remote control planes or cars or the like. What this teaches, however, is the principle behind wheel-based movement, not only in terms of moving backward and forward, but also ideas like single wheel versus double wheel rotation, which are valuable when it comes to programming wheeled movement. The second level is programming without coding. This involves using the variable control board to program various robotic outcomes without having to upload a code. This level is designed to teach coding logic to students, so they will be prepared to understand these functions when they enter a coding environment. This includes logic such as if-then and if-then-else statements. The final level is programming with flip code. This is where students will take what they have learned in the previous 2 levels and apply it to our Blockly Arduino coding environment. This e-learning module will look at the first 2 levels of coding. There is a separate e-learning module for flip code for further information on this topic. We will now look at the first default firmware mode for FlipRobot, which utilizes the remote control to move FlipRobot. Before we begin coding, we will need to download the Chrome extension and relevant drivers to download both the default firmware as well as any coding performed in FlipCode. The extension file allows FlipRobot to talk with your computer to receive the coding files. The Chrome extension files can be found on the support page of FlipCloud. The extension file and drivers for all operating systems can be found on this page, so if you haven't already, go ahead now and download the file relevant to you from the support page. Once the file has been downloaded, be sure to save it somewhere on your local machine where it is easy to locate. When you have done this, you will want to launch your Chrome browser. From the home page, select the menu tab as shown, head down to More Tools, and then select Extensions. Once the extension page has loaded, all you need to do is drag the extension file you saved earlier into the extension page and accept to install it. You are now ready to upload the default firmware required to program through the variable control board. Your FlipRobot will have the default firmware loaded on it when you first take it out of the box. However, if you use FlipCode and load a program from this, it will overwrite the default firmware. To use the variable control board, the default firmware will need to be loaded back onto FlipRobot. To do this, all you need to do is head to the Case Curriculum section of FlipCloud and then select the topic you wish to download. For the purposes of this module, we will select Topic 1. Once in the topic page, you will notice at the bottom right there is a section for firmware. Once you have the robot connected to your computer and the robot turned on, you can select the brain and port from the firmware drop-down menus and press Upload. After about 20 seconds, you'll be notified of the successful upload and the robot will flash and make a musical chime to indicate this was successful. Now go ahead and upload the Topic 1 default firmware to your FlipRobot, and once done, you can continue with the e-learning module. When you turn FlipRobot on with the default firmware loaded, the mode the FlipRobot will start in is the remote control mode. All you need to do is attach the remote control, as shown, to use the remote control to move FlipRobot. Now that the remote control is plugged in, you'll be able to use it to control the robot. Each side of the remote control is used to move one of the wheels of FlipRobot. Buttons 1 and 2 move the left wheel forward and backward respectively as shown. Buttons 5 and 6 move the right wheel forward and backward as shown. In the default firmware mode, buttons 3, 4, 7 and 8 do not affect the robot. However, these buttons can be programmed in FlipCode to perform different actions such as sound the buzzer. Go ahead now and practice having the robot move straight, as well as doing left and right turns using single and double wheel rotation. While students will be utilizing the remote control, they'll be learning to become familiar with the concept of wheel-based motion, the difference between single wheel and double wheel rotation, thinking of each wheel individually for coding purposes. These skills will be important when we move into the coding without programming level. We will now look at coding via the variable control board with the remaining default firmware modes. This is where we will begin teaching coding logic concepts by coding the various dials of the variable control board. You will no longer need the remote control, so feel free to disconnect it from your FlipRobot before proceeding. We will now look at the two ultrasonic sensor modes in the default firmware for FlipRobot, discussing the learning outcomes and how to program the FlipRobot in these modes. The ultrasonic sensor and obstacle avoidance activities are used first, as they are used to introduce students to the concepts of if and then logic. If and then logic is a key principle in coding, where a parameter is set and depending upon the result, an action is initiated. Looking at the flowchart shown, you can see how obstacle avoidance challenges utilize if and then logic. The if decision comes from the robot sensing a wall, and if the answer is yes, the then statement is what direction you wish the robot to turn when sensing the wall. This is the program we will look to create using the variable control board shortly. To change firmware modes on FlipRobot, you will need to use the Mode button located at the top right of the FlipBrain as shown here. Pressing this button will cycle through the various modes of the default firmware you may have loaded. Pressing this button once, while in the remote control mode, will enter ultrasonic detection mode. In this mode, you can test whether the ultrasonic sensor is working by putting your hand in front of the sensor, and the light should change from orange to red as shown here. Pressing the mode button once again will enter ultrasonic sensor mode. It is from here that we can program the variable control board and ultrasonic sensor. It is worth noting that in this mode the FlipRobot will react to whatever the values on the variable control board are, and as such may begin moving. We recommend making sure the wheels are not on the ground when switching to this mode to avoid the robot accidentally running away. To program the variable control board depends on the positioning of the dials while the FlipRobot is in a mode that utilizes a sensor. If you look closely at the dials on the FlipRobot, you will see a small arrow inside the dial. Where the arrow is pointing will indicate the value assigned to that function. The first variable control board programming we will look at is how to calibrate the DC motors. No two motors are designed identically, as there are small differences which can affect rotation speed, even if the motors are programmed to be at the same speed. On the variable control board, dials 7 and 8 control the speeds of the left and right DC motor. To calibrate the motors, first ensure the FlipRobot is in default firmware mode 3. Once it is, set both dials 7 and 8 to the far right using your screwdriver and put the FlipRobot on the ground. You'll now see which wheel is moving faster by which way the FlipRobot veers. From here, adjust the speed on the faster motor to bring it in line with the other motor's speed. It's now your turn. Follow the instructions provided to calibrate your motors so your FlipRobot moves in a straight line. Now that the motors have been calibrated, we will look at programming the if and then logic to perform an obstacle avoidance challenge. To program the ultrasonic sensor, there are two parameters that will need to be programmed. These are the direction of the turn when detecting a wall and how long FlipRobot should turn after detecting the wall. Dials 1, 3 and 5 dictate what direction the robot will turn when encountering a wall. To set the direction, the arrow on the dial merely needs to be pointing in the direction you wish to turn. The degree at which the dial is turned to the left or right does not matter. As long as the arrow is pointed in that direction, the robot will turn that way. Dials 2, 4 and 6 dictate how long the robot will turn once it has detected a wall. This programming will require a little trial and error, as this parameter can be different for each robot. Our recommendation is to set all three of these dials to the 12 o'clock position, which should roughly make the robot turn on a right angle. From here, you can make the necessary adjustments if the robot is turning too sharply or not turning enough. To run the ultrasonic program again, you can push the reset button at the back of the FlipBrain and select mode 3 again, and the program will run with the changes made to the variable control board. Let's put your programming skills to the test now. Using what you can, set up a course like the one being shown. Your goal is by only using the variable control board, getting your FlipRobot to run the maze as shown. Once you've completed this, we'll be ready to move on to the next firmware mode. We will now look at the RGB color combination mode in the default firmware. Adding color into a coding activity allows students to bring their own creativity to a project or simply add a bit of their own personality to the robot. The RGB function also teaches the relationship between colors, with students needing to mix different ratios of red, green, and blue to get the color they specifically want. The RGB color combination mode is mode 4 in the default firmware for topic 1 and directly follows the obstacle avoidance mode we used earlier. To reach this mode, from turning on your FlipRobot, press the mode select button 3 times and you'll be in RGB mode. The variable control board in RGB mode is used to determine how much of a color is shown for both the left and right LED lights. If we look at the left LED first, we can see that dial 1 determines the brightness of the red light, dial 3 determines how bright the green light is, and dial 5 determines how bright the blue light is. By mixing the brightness of the light, you can make colors such as yellow, cyan, and magenta. This configuration is replicated for the right-hand LED, with dial 2 controlling red, dial 4 controlling green, and dial 6 controlling blue. In this mode, dial 7 and 8 are not required. Now it's your turn to experiment with different colors that can be created in the RGB LED mode. Once you're done, we will look at the next firmware mode. We will now look at the final firmware mode that uses the infrared sensor to perform line tracing activities. When using the ultrasonic sensor, we were introduced to the concept of if and then statements, whereby if a certain criteria is met, then an action is taken. The infrared sensor builds on this by introducing if, then, and else logic. This is where there are two possible actions based on a certain criteria. Let's look at some real-world examples of if, then, and else logic. When driving along in your car and you see a traffic light, as an example of if, then, else logic would be, if you see a red light, then stop, else continue driving. This is the logic we will look to employ in line tracing activities, as we will need to program the robot on what to do in different circumstances while tracing the line. The infrared line tracing mode is mode 5 of the default firmware for topic 1. To get to the line tracing mode, from turning your FlipRobot on, press the firmware button 4 times and this will enter line tracing mode. To code line tracing activities using the variable control board, it is all about what you want the FlipRobot to do depending on how much of the line it detects. If you look at the infrared sensor on your FlipRobot, you will see it has a left and right sensor, and the coding is linked to what each of these sensors is detecting. We will run through the purpose behind each dial individually to best explain how to program a line tracing activity. Dial 1 controls what you want the FlipRobot to do if both sensors can detect the line. In this instance, the dial should be set to the forward position, as you would always want the robot to move forward when it is on the line. Dial 2 controls what you want the FlipRobot to do if only the left-hand sensor can detect the line. In this instance, the robot will be veering off the line to the right, so we'd want to set the dial to the left position to correct this and have the FlipRobot turn back onto the line. Dial 3 is the reverse of dial 2, whereby the FlipRobot is veering off to the left, so you would want to set the dial to the right position to correct this. Dial 4 controls what you want the FlipRobot to do when it cannot detect the line on either infrared sensor. This can have different uses depending upon the line being traced, but as we were looking at tracing a circle, it is recommended to set this to the left if you plan to go clockwise, or to the right if you plan to go anti-clockwise. Dial 5 controls the forward speed of FlipRobot. Unlike the ultrasonic sensor, the variable control board controls both motors the same in this mode. For line tracing activities, it is recommended to not set the speed to full, as the sensor may not be able to keep up with the rate of change of the line. It is best to set this to the 12 o'clock position and then adjust if too slow or fast. Dial 6 controls the rotation of FlipRobot. This is how quickly the FlipRobot will correct itself when veering off the line. Similarly to the forward speed, it is best not to set this to full, as it can cause the FlipRobot to sometimes overcorrect if set too fast. This is also best set to the 12 o'clock position and adjusted where appropriate. Dials 7 and 8 are not required for line tracing activities. It is now your turn. Using the variable control board and the circle map that came with your FlipRobot, program the FlipRobot to trace the larger circle. Once you are done, you can continue with the course. This concludes the e-learning module on programming with the variable control board. Over the courses module, you will have learned what is firmware and its importance in machines, how to upload the default firmware to your FlipRobot, how to use a remote control to move your FlipRobot, how to program the ultrasonic sensor using the variable control board, how to program the LED lights using the variable control board, and how to program the infrared sensor using the variable control board. There will now be a short quiz to go over what you have learned, and once you have passed, you will have completed the course.